Josh received like a message saying like somebody had to go to the hospital.
Yeah, it was Kai.
Like a bad concussion?
Yeah, we had fun.
Yeah, we like took him to the ER.
Ooh.
He got knocked out.
Oh.
Yeah.
Scary day.
What were you skiing? Was it you had a race, right?
Yeah, we had a race. It was just like he got on the tails of the skis and
Yeah, her head doesn't hurt.
right on his face.
Miraculously.
Molly's fine.
Chris,
Molly's
did you see
fine.
what happened?
To Tucker?
To Molly.
Molly. No.
Is it up on?
No, I don't know the video, but apparently it's really bad, but this is her helmet.
Yeah, she cracked the helmet.
She cracked her helmet?
Like literally in half. Look.
Thank God for helmets, huh?
Yeah.
That's like what they're supposed to do.
Exactly. People are like
Yeah.
going crazy, but I'm like, that's what they're designed to do.
Yeah.
'Cause that's how you release the energy.
So many people are like,
Right,
really
Chris?
good this year.
Exactly.
Right?
Love
People are
that.
like, what
Love
do you mean release energy? I'm like, okay, here we go.
Oh, boy. Basic physics. Come on.
Basic physics.
Are you in physics?
What? No, it's just common sense that like
Basic understanding of things.
every action has an opposite and an equal reaction. So
Have you ever taken physics?
No,
You
but
should take physics.
maybe I should.
You should.
Next year.
Yeah.
That's hard now.
No, you'd love it, right? I think.
I feel like I would.
Yeah.
Physics. Then I'll design a helmet that's concussion proof.
Totally. Yeah, you should take engineering.
Nips,
Yeah.
kind of.
All right. So I think it's just us today, right?
Yeah, because Sean and Tom, it's -26 there. Tommy put something on their like Snapchat
Yeah,
story
but
and
it
then
feels
up
like
top.
negative 40.
Oh.
Like,
Yeah, the GS suit.
So let's go over homework.
thinking that we're too bad to go.
The first ones are all right. I
Can we go
hope.
over?
What's that? We did it?
29.
29.
Wait,
Yeah.
is 29 with a homework?
That's like the
It is. Yeah.
This one.
Yeah, this bad.
Cool.
49,
I
This
like
one was
this
just
one.
annoying.
I would like to do
Annoying.
Yeah, it took a like annoying long time.
This one
Not
just
like a
seemed like
long time,
a
it's
lot
just
of.
like-
29 and
annoying
then
amount of
45.
time.
Not, it was just like annoying.
So 29, we're saying A is 15.
51.
So this is 15. C is 25. D is 20.
Some Chris.
Oh, I just wrote C. Yeah.
Oh, I started that one.
Oh.
That's good.
How was skiing yesterday, Chris?
It was alright. We already talked about it at the start of class.
Yeah, that hurts.
God.
So, you gotta use some properties of parallelograms in this one.
I forgot all of them.
What's that? Yeah, well, we're gonna
Yeah, geometry's too long.
I just divided all the numbers in half.
So one of the properties of parallelograms is that their diagonals get off the internet chat. Their diagonals intersect each other, right? Which makes this length also 20. Which makes this length also 25.
Oh yeah, I know that part.
Okay.
Okay, I'll resign.
What's that? What are you talking about?
I can't even resign. Chris, I have to play. Oh wait, it's like that? I just assumed the whole C.
Oh, so if I get that, I get the whole thing.
What's that?
I just
I
assumed
got
the
it.
25 was the length of the whole line.
No.
Oh yeah.
Ooh. Oh, no, it is, isn't it?
Is it the whole line?
That's okay. Still, we're fine. Right? The whole line. But I can say that this is, since it still intersects,
Yeah.
right? And this length is 10. And this length is 12.5. Right?
Yeah.
Now, if we have that, that would give me this angle, which would give me this angle, right?
Yeah.
I can find this angle here,
Yep.
which gives me this angle is the same.
How did you find,
Wait.
how did you find 10, 12, 12.5?
It's a property of parallelograms. The diagonals intersect each other, bisect each other. Sorry,
Bisect, yes.
bisect.
Right? How do you know? Oh.
Right. So
So
now
then you can
yeah.
have all the.
I'm not gonna
angles
go
of that.
through all the law of cosine work because I think we did it yesterday. But we can find this angle, right? We can find that angle. We can find this angle. We can find this angle, right?
C is not.
Yeah, because you're 15, 12.5.
C is not 12.5.
Yeah. No, C's not, but half of C is.
Oh, I probably could.
Half of C is.
Wait, so C is the whole thing.
Yeah.
I thought it's like that segment there. And then
It's
I
all
was
good. It's all good.
God dang it.
Right? Okay, so that's something. That's something. And then, let's see, what else? We know this length here. Oh boy, what happened? We know this length. If I know this length and that angle, I can solve that triangle. If I know, I can solve every piece of this now, right? Oh no! So if I can solve for this part of theta, and then that part of theta, and this part of phi, and that part of phi, then I'm all good, right? Right, I would use law of cosines to find this angle and this angle. I'd use law of cosines on the big triangle up here to find this angle and this angle, right? Because if I have that 10, that 12.5, if I find this angle,
Oh, you
this
know
angle's,
that.
this angle's
Yeah.
the supplement of it, right? It's 180 minus that angle. And so it's a little puzzle. But in the end, you're just using law of cosines and stuff.
I actually memorized that.
You did?
Yeah.
Yeah.
What?
The law of cosine.
Yeah, it's really not that, no, it's really not that hard of a one to memorize, right?
No.
It's one of the sides squared equals the other one squared plus the other one squared minus 2 times those other two cosine.
The first two.
Yeah, we can get it. Okay, so let's look at one of these ones with bearings, right?
Yeah.
That Michaela got
I was
already
just
mad
like,
at me
what
about.
is that?
Now, what is
I
bearing?
think there's something wrong
I
with
used to
my
study bearing, but I
calculator
forgot
Yeah,
settings
that one I
because
didn't understand.
Something wrong with your calculator?
yeah, because it would give me not
Mine's
right
just
answers.
Is it in degrees?
I changed.
Wait,
Jason, you want to look at my
Mine
calculator?
just only
again?
works like.
no.
There's 2 bearing problems? What is
you
your
wanna have
bearing?
my calculator?
Let's do this one.
Do you want to
So
see?
good.
I think my settings are messed up. 'Cause it's not
I don't know how to do that. Jeez. I'm already bad at calculating.
It's okay, what do you need?
I'll figure it out.
Will you?
If you change the,
Oh, look,
if you
here's
change
the-
the angle, if you change the angle
I
measurement,
have that one.
Ryan, if you change
Yeah.
the angle measurement, instead of just pressing OK, press the button that says make default.
Okay.
Sometimes it gets funny like that. Okay, so let's start out by you guys just tell me what you found for these angles, right? Even if we couldn't figure out the bearing piece. What's this angle?
13.1
Which one?
is the Phoenix angle.
This angle, yeah.
And then, I don't know.
And then,
I didn't
anyone
know
else
bearing-
find any other angles?
I didn't know what bearing meant, so I just like.
Bearing, yeah.
I used to study that.
That's okay.
And
That's
then I
okay.
forgot everything.
Yeah, bearing is just from north, east, right? Whatever the angle is from north, and you
So like-
wrap around east to south to
Which-
west.
Let's do like
180
in a
minus
60
that, right?
degrees.
What's
You're
that?
going like that.
Yeah, so like the bearing from, we're looking for the bearing from Minneapolis to Phoenix,
That's where you
Yeah.
right? This is gonna be the measure of the bearing, right? The angle that's formed like this here,
Oh.
okay? And we know that this is due west, right? Okay. Did anyone find the angle here for Minneapolis angle?
Oh, that one?
Yeah,
The inside one, or the outside one?
the inside one, just
Oh.
this big angle. Did you find it?
I think it's something. Let me check.
Okay, cool.
How'd you?
Figured it was something.
Good question. Is it?
We could do it pretty simply, right? We could say that the sine, now that Shaw told us that that angle is 13.1, What's that?
You use the law of cosines.
law of cosines, right? So Shaw, he said,
You
if
memorized
we
it, you know how
had,
to use it.
we could say the sine of,
Is
we'll
it
call
question 51? Yeah.
What?
Is it question
Yeah.
51? Yeah.
51.
It's 149.7.
That's 149.7,
Yeah.
okay. 149.7.
Minneapolis? Yeah.
Yeah. So if you're looking at the bearing from Minneapolis to Phoenix, basically you're just gonna say it's this 149.7
No.
from here
Oh, yeah. Oh, yeah.
to here,
Yeah.
right?
It's 149.
plus 90 degrees,
Yeah.
and that's it. Right? That's nice yellow.
Yeah, that's bright.
That really helps. You guys see, I'm sure on the video it's helping.
Yeah.
What do we got?
Hey,
Video
guys.
review.
239.7 is the bearing, right?
Run.
So bearing is just from north the angle that's formed clockwise.
Wait, what is it?
Yeah, because it's in the wrong color.
Chris?
Yeah. Oh, God. What?
Chris, it's like when I use law of sines for like the very first problem,
Is that the cool?
Yeah.
the 13, like I get angles, degrees that equal to not 180.
When you do what?
It's like if you look at the I got angles degrees that doesn't equal to 180. Does that mean that there is another alternative like an angle like 180 minus one of them that equals something that?
Which one did you solve with the law of sines?
I saw. No, I'm not talking about.
Oh,
Wait, what is the bearings just from the north?
it's from the north clockwise.
Are you supposed to find the
Wait,
small
what?
one first?
Sorry, what's the plus 90?
So this angle here is from this point
Oh, it comes
over to
up.
here, right?
Wait.
So that point right here, since that's east-west, we can say that it's coming from 90 degrees past
Oh,
north,
okay.
and so we just add 90, tack onto it. I don't understand what you asked me for a question.
So basically just if you can plot 13.
Yeah.
So like you use cosine, right? And
Mhm.
log cosine, and then I figured out angle A,
Uh-huh.
and then I
What was angle A?
it is 30.1.
38.1, great.
30
Fantastic, yeah.
Yeah, and then I used the law of sines.
To find
30.1 times 15 divided by 11, right? So
divided by 11, that should still be an acute angle,
that's 43.1.
okay?
And then I used 30.1 times 21 divided by 11. I got 73.2.
Okay, but that one also, because angle C could be obtuse, right?
Yes, so 180 minus angle
Yeah.
C could work.
Yes, yeah, right, anytime you're using sines, right, because the sign is positive on the first two quadrants, right? It could be anything between 0 and 90, or it's supplement when you're using sines, right? That's why, always a good idea to, try to not use the law of sines with the angle that's opposite the longest side.
So
Does that
what's
make
the
sense?
answer?
For this one?
No.
Oh, for that one. The answer?
149.6.
Yeah, I think it was
Really?
added pages. Oh boy, it's embarrassing.
How embarrassing.
How embarrassing. Yeah, 149.6 is the angle, right? And then the bearing is, since this is east-west, right? This angle is 149.6, right? A bearing is measured from north counterclockwise, so I'm just gonna tack on this extra 90 degrees. And that's how I got the bearing, right?
Wait, but how do you know that's parallel?
What's that?
How do you know that's like parallel, or?
Oh, it's given that it's due
Oh, it's
west.
due west,
Yeah.
okay.
Wait, so wouldn't the other one just be like?
Due west is like
270?
straight
What's that?
west.
This bearing?
What number is the Albany of Phoenix?
Yeah, Albany to Phoenix,
Oh wait, no, never mind.
right, you're gonna,
This dude.
Do you like find that angle and subtract it by 270?
yeah, you're gonna find this angle and subtract it from 270, exactly. Fantastic. How'd the parking lot one go?
Awful. It just
Oh, that one went
You
really
guys
well.
get scared by it?
You
No,
just
it
find
just-
the height and then it's just based on
It's you can just look at the
But I
outside.
thought it was like one half
The parallel.
is
Wait.
sine C.
Because the area of a parallelogram is just based on height. So you just I just drew a line down from the 70.
Oh yeah, that's one way to do it for sure,
You just found that.
right?
Wait, how do you find that?
You just, that's your.
Because you
angle.
know,
Oh, yeah.
I use like the
I
sine.
like it.
I use like 70 over sine 90 is equal to b over sine 70.
Yeah, cause it's 90 degrees.
Yeah.
Yeah, right.
Yeah, this is, to find the height, right, you can do one just straight from the other, and that's a great way to solve this one.
I don't know. It's just based on-
So then you got, this is h, so h equals 70 sine 70 degrees, that length of 70, right? Because sine 70, that's a 7 equals h
H
over 70, so it comes to
Okay.
that, right? And then that'll give you the height. What was the height there? 70 sine 70?
I did.
What was your final answer?
Okay.
It was
65.8?
65.8.
Okay, so 65.8,
And
and
times
then
that
100 times 65.8 is 650, no, 6,580. Fantastic.
That's a lot of square meters.
That's a lot of square meters. I gave this like end of term project for my Algebra 2 class using law of sines and area and stuff.
Algebra 2.
Algebra 2. And I did like this old map of campus, and I did like an overlay, and I had to draw triangles to like just break it all into triangles.
Oh, and then find the area.
And then find the area using like a scale.
That's pretty cool.
It was an alright project, but I had somebody come back at the end and said it was like 9 square feet. It's like, I think you might have missed something.
Couple zeros.
Alright, does anyone know what a vector is? This is the new unit.
Vector.
I think I've heard about it before.
Oh yeah, vectors. That ugly
Well, 'cause, like-
assault rifle thing.
It's probably, yeah, that
It was
ugly
like-
assault rifle is probably named off after the concept of a vector.
Really?
Yeah, vector is any measurement that has,
Oh,
Both.
yeah, it's like goes
Oh,
down
I
infinitely or
remember.
something.
it's a measurement that has a direction
Yeah, direction, yeah.
and a magnitude, right? A direction and a size, right?
Hmm.
So, like if we were to look at a couple of things, like, so measurements are either categorized into a vector or a scalar, right? A scalar just gives scale. So like, let's say some following measurements, you tell me if they're vectors or scalars. Time.
Scalar.
Scalar, right? You're not measuring time in a specific direction, right? We're not talking about negative time in terms of how to measure time.
I don't understand what that means, but
What's that?
what does that
Oh,
mean?
because time is a concept.
Well, it's because time is just something that continually moves forward.
Oh.
Okay, Jason.
Right?
Okay.
Wait.
So like velocity is a vector.
Velocity would be a vector, right? Velocity would be a vector and speed would be a scalar. Speed is how fast you are going. Velocity is how fast you're growing
In a
and in
given
which
direction.
direction, right? So velocity would be a vector. Force is given as vectors, right? You can push on something in a certain way, like if I
Also,
push the
vectors
table
is
this
like-
way, it'd be different if I push the table this way.
So vectors in a direction, right?
Vector has a direction and a magnitude, right?
Scale-
Algebra 3.
What's that? Scalars do
What is
not.
math?
No.
What's that?
What is math?
The size.
Oh,
You
sorry.
can.
Big. Yeah, bigness.
I mean, why,
Right?
why not?
So we're talking about vectors, and we're talking specifically how to represent them mathematically, right? A couple ways. The first way to represent it mathematically is graphically, right? Graphically. So if I had a vector that was showing the displacement from R to S, right? It would be drawn like that. Now what's interesting about a vector is even though they're in different position, these two vectors that are here, they're actually the same vector because they have the same length and the same direction. Does that make sense? Right? Even if we don't understand much about vectors yet. Right?
Does distance matter?
Distance matters, right? The distance from point A to point B, right? That length, that matters, and then the direction, the angle that it's pointed at, right? So this vector and that vector are exactly the same because they have the same length and they're pointing in the same exact direction. Okay?
So it's like slope.
Yes, slope. Yes, slope is kind of like an explanation of what the angle is. Yeah, okay. So that's a start. Okay. Some vocabulary, right? First, magnitude, that means how big is it? Direction, what angle is pointing at. And then the concepts of initial point and terminal point, right? A vector starts somewhere and ends somewhere. That shows you which direction it's going. If I didn't have an initial point or a terminal point, that vector could be going in the exact opposite direction. Does that make sense? Yes, no?
Yeah.
Okay. It's okay, we're gonna be okay. Come on.
No.
No, forget this. We don't have to talk about that. Okay. Oh, this looks scary, but it's not too bad.
No,
Do you-
no.
is there like a sheet with this?
That's,
Oh,
is that kind of just like
do we
the
have to
distance
copy it?
formula?
It is.
Yeah.
This is Pythagorean theorem, right? Which is the distance formula, which is how to find the length of a vector.
Yeah.
Yeah, and we're gonna go over stuff, right? So the first thing is, this is notation that is gonna be used for a vector. So for that vector we saw before with the point P and Q, it's written as PQ, where P is the initial side and Q is the terminal side, and so that little arrow points towards the end of the vector, okay?
Do you want us to copy this out?
Yeah, copy down like this statement.
What? What does that
What?
that thing? Oh, is it just parentheses?
Parentheses, yeah, it's not parentheses.
Oh.
Actually, what are those called? I cannot remember.
What do those do?
What they denote is that you're talking about a vector.
Oh.
And what you're talking about is the length of the x, the change in x, which is the v1, and the change of y, which is v2.
That looks That looks just like distance from.
It is the distance formula,
Oh,
Okay.
right?
almost like I just said
It's
that.
almost exactly, it is the distance formula. The last statement about unit vectors you don't have to write down yet.
Wait, what is it?
Do we have to write down the magnitude?
Like weird
Wait, what
parentheses.
Yeah, magnitude, yeah, I can't remember what
Wait.
they're called, but they denote that you're talking about a vector.
Chris, is
Okay,
it?
so that's what we have to use instead of
And what the V1, V2 means is the length of the,
They're
in
kinda
the
like
x
random.
direction and length in the y
Wait,
direction.
what is
Yeah.
it times Q2 or is it? What is that? P1 times Q2? Like.
Is that a
P1,
comma?
where do you see P1 times
So you see
Q2?
how
Comma,
Q-
comma,
oh,
comma,
Oh.
comma, right? Basically, it's just saying what the vector is being described as is this change in x from the starting point to the finish point and the change in y from the starting point to the finish point, right?
That looks really hard.
It's called component form because we're talking about the horizontal component of the vector and the vertical component of the vector, the x component and the y component. XY. And then that notation, that the double line that like kind of looks like double absolute value, that means magnitude. That means the size of it.
From absolute value.
What's that?
It's like distance is like absolute value. Nothing.
Alright, we're gonna get this. Got
Yeah.
a lot of notation getting thrown at us.
But
right
what's the
now.
difference between this two?
To what?
The distance and slope.
Yeah, a lot of it is just a different way of expressing it, right? And we're going to talk about vector addition and vector subtraction, vector multiplication, and some of this stuff's going to make sense when we start doing it. No, I think it will. I think it will. You good, Kayla?
Yeah.
You good, Ming?
Mm-hmm.
Okay. So, who says that I want to do stuff for me?
Because the board hates you.
You think the board hates me?
Yeah.
Let's
Okay, whatever. So, let's actually do, let's put in a graph here. Put in a graph. So this is what my vector looks like. We got the initial point at 4, -7. 4, -7. Here. That's my initial point. That's I'm not giving anything to it. And then the terminal point is at 1, 5, right? My vector looks like this. Okay. Now, if I want to write about it in terms of component form, right? What I'm going to do
Oh,
Right.
more triangles.
is I'm going to look at the change in x and the change in y. And that's basically all that thing said before, right? So from the initial point to the terminal point, how far has it moved in the x direction?
5.
Yeah.
Yeah,
5, right? So we can call this vector v, right? And it's 5 and it's 5 left, so I'm going to call it -5. Okay?
Wait, that symbol just represents vector.
Yeah, that's that bracket.
Okay.
It's just,
Oh,
I'm
you're doing-
making mine a little more
Oh,
severe.
you're
I'm
doing-
writing it in component
okay.
form first.
Okay, yep.
Right? Now, what's the change in y from the initial point to the final point, terminal point? 12. Yeah.
Oh,
Right?
positive.
So that's as easy as that, how to write into component form, right? And component form just kind of gives you an overall idea of how big it is and what direction it's going. Now, if I want to find the magnitude of v,
That's vector form, right? Oh, no.
that's component form, yeah.
Wait, is it math? Wait. Okay.
So that's vector component form.
Okay.
And now we're finding the magnitude, which is just the length of it, right? How would I find the length of that blue line?
Pythagorean theorem.
Pythagorean theorem, right?
Yeah.
Is just going to be equal to the square root of the change in x plus the change in y.
Isn't that also just like the distance formula?
It is the distance formula. Distance formula is Pythagorean theorem.
It's all the same.
They're all the same thing.
That's so the blue line is vector.
The blue line is the vector. The green lines are the vector components, right? This vector has an x component of -5 and a y component of 12, right? And that's just the displacement in the x direction, displacement in the y direction. This really helps when we start talking about adding these vectors together. Let's see. Do I have one? Okay, so I don't need you to write this down. I think we're gonna get it from what we do. Oh, the other piece, the book. There's two ways that they write vectors. They write either in this notation, that PQ, 2 points with a line on top. Often they just write it as a bold letter. The book does. Right? So just be aware that that's what they're talking about when they have a bold letter.
Oh, math, too much.
Oh, math. Okay. Cool. So now, if I want to add two vectors together, right? I want to do
U plus.
Okay, so this is u minus v. Let's say I had u plus v. So let's do that. So if I did, let's actually do u plus v. Okay? That's vector v. Right? That's vector u. If I want to add u plus v, what I would do is I would take the vector, if I wanted to do it like visually, graphically, and do like what's called tip to tail addition, right? So I'll take this vector, I'll move it
Whoa.
to there.
Wow.
Isn't
Right?
that like a change in direction?
And then the new vector
Oh.
is u plus v. That's the new vector, right?
Why is it u plus v?
Right? Because I took
Oh, yeah,
u
yeah, yeah,
in its entirety, and then I moved v up and put it at the end of u, and I added them like that.
Oh, yeah.
Okay?
What?
Now, if I wanted to do u minus v, which is what's shown here, right? I'm going to take u and then move v in the opposite direction, flip it, and then I'd measure from the very starting point of u to the very ending point of v. Yeah.
What is the, why is that negative v and the lower one is v?
This is positive v here
Yes.
because initial point, terminal point. This is negative v because initial point,
Wait, why
terminal
would
point. It's going the exact
why would
opposite
yeah,
direction.
U minus V be going the other way?
So u minus v is still going to be the entirety of u first, right? And then basically we're going to add negative v, right? Addition and subtraction are essentially the same thing. So I'm going to add negative v, and all negative v is the director, the vector in the exact opposite direction, right? So if this is positive v, then negative v has the
Oh.
initial point here and the terminal
And then
point
it's
at
just
the end.
going this, so it's the same.
Why do you That's not it.
Wait, I'm really confused.
Thanks, Jason.
Apologize.
Yeah. Okay. Let's pick apart what you're actually
Why does
what
this
you're really
matter?
confused at. What's that?
Why does this matter?
That matters a lot.
Why?
How
Um,
much?
Is that? It doesn't matter much? No, it matters quite a bit.
Is U just another number or number letter?
U is a vector.
Is it just another vector
It's
though?
just a different vector. U is a vector, V is a vector.
Okay.
To combine them, I'm either gonna add them or subtract them.
And that's all what it would look like if you combine them.
Uh-huh.
And what's the plus V?
The plus V? Yeah, so the U plus V is if I added U to V. The U minus V is if I added
Right.
negative V to U.
Why is it like that?
Why is what like that?
U plus V.
Yeah, let me, this length right here is U plus V, right?
Oh.
It's from the start of U to the end of V. This length here is U minus V.
Right. I understand that part.
Okay. Does that make
Do we
more
need to
sense now?
understand like how to get it? How to get those?
How to get those?
Like why it makes sense?
Do you understand why it makes sense?
No, that's the part I don't understand.
What is this?
Okay. So, let's think of it in like terms of a real world physical situation, which is why adding vectors matters, right? So say like,
If you draw on the whiteboard over there.
okay, so say I've got, for example, I've got like a river, okay? And I'm on a boat,
It's a vector.
right?
Yep.
The river's not a vector.
Why?
So
But
this-
it's going.
The river is just a river.
Okay.
Okay. So
It's a scale.
I've got this
It's
boat,
body plane.
right? I've got this boat, and this boat goes 4 miles per hour if I paddle it as hard as I can, because I'm slow.
4 miles per hour.
Yeah, 4 meters per second. Who cares? Some speed, right? Okay. So I got the boat. It can travel some speed. Right? We'll call that. Now, the current is going 3 meters per second, and the current's going this way. Right? The current's going 3 meters per second. So I'm going to add that current
Oh.
onto the speed that I can travel.
Right, and then you
Those
just
are
do that way.
right. And now, yeah, so now if I
U
want to
plus
know
V.
my overall speed and direction, I'll add those two vectors together and find that I'm going 5 meters per second total speed, not in the direction that I'm paddling though, right? If you ever paddled a boat against the current, you want to go this way, and you just kind of drift at an angle up river, right? Which is why if you ever want to like land a canoe or something, you paddle at an angle upstream, and then you kind of go sideways into the shore. Yeah.
Isn't that? I'm just supposed to square that. Square the length of both.
Yeah, so I want to do it with numbers. Do you want to do some addition?
Why
with
does it?
numbers?
Why is minus
Yeah,
V?
because I
like,
mean
way
that's
above
3,
it?
4.
What's that?
Why is minus V above it? Is that just a show?
Above where?
Above V?
Oh, so this is saying you're doing U minus V, so you take
No.
U,
Just V.
and then, so yeah, but
Oh,
still,
okay.
to do U minus V, you take U, go to the end of it, and then you're gonna add a negative V vector, right? This is the positive
Oh,
V
okay,
vector.
yeah.
Negative V vector goes in the other direction, so I start the point of it there at the end of the last one, and go to the end. And this length is U minus V.
And then so that one's like U minus V, U minus U minus.
Yeah, what's the difference between U?
Oh, why is this one here?
Yeah.
Oh, I see.
It's the same, these two are the same, they're just in different places.
Oh, okay.
They're just in different places,
Just a show.
just to show.
Chris, is it like if like there's like a river going like this way?
Uh-huh.
I mean that way, and U is like a boat, and the boat goes forward while
Right,
V
it's
is
like saying,
pushing
it's like
it
saying
far.
the U is
Yeah.
the boat, and
Right.
the river's pushing it this direction, so you end up going like halfway in between, or partial way in between, okay? Let's do it with some numbers, so like maybe this stuff will click a little bit more.
No, better be.
What's that?
Better be easier.
Or.
I know what I'm talking about. Sorry, my
What
bad.
are you gonna do?
I'm just a little bit sleepy right now.
I'm so
That's okay. So we got these two vectors, right? So, actually let's start with something a little more straightforward. Let's first just do, I want to find V plus W. Alright, put the graph up. And we can take a look at it. Visual, like a visual interpretation first, right? So we got V. V is -2, 5, right? So if I start at the origin, which is fine, I can start wherever I want, right? V is -2, +5. Oops.
This has serious problems.
What the? Oh no, it's me. It's operator error. -2, +5. That there's is U, right? So far, so good.
Yeah.
V is 3, or W is 3, 4. So if I'm gonna add it to U, I'll go over 3 up 4. That's V.
And then V, wait, you mean W.
Yes, I did mean W.
So then that, from the origin to where W
And that was V.
ends
Sorry.
is V
Oh, that's
plus
horrible.
W.
Right? And then this length here,
Choose those together.
this length here is V plus W, right? So it's the simplest way to look at it, right, is to find V plus W in its new component form, right? Equals -2 plus 3, comma, 5 plus 4, right? And now I've got 1, 9, right? Which if I look at this vector, I'm 1 over and 9 up.
Wait, how is that 1 over?
This is 1 from the origin where I started, right? This
Oh,
from this
right,
point
right.
here, from this point here is 1 to the right
Yeah.
and 9 up. 1, 9.
I have a question.
Yeah,
Does that work the same if you do W first?
it is, right? It absolutely is, right? And I can just move these around, right? I could do, oh boy. Right? And you can just look at how it works like this.
Oh, it's just like a symmetry.
Exactly, right? It doesn't matter which order we do it in.
So
It
does
shouldn't
that
matter
be-
because addition can be in either direction. What's that?
Wait, that would just be them.
It's just saying
Opposite.
that that's
Yeah.
just W plus V instead of V plus W.
Yeah.
Are we doing? Oh no, we're just doing V plus W.
Mhm.
Oh, okay. I
Yeah,
thought you
that's
were
all we're doing.
like-
This is the new one here, right?
Yep.
But, right, if I was to do 2V, right, all I'd be looking at is this, and then doubling its length right there, right? So 2V would just be equal to -4, 10. Right, just twice of both ones. W minus V
You just multiply by 2.
would just be
The chord.
5, -1, right? Just W minus V,
Right.
right?
Wait. Oh, you just minus it. Oh, you just do subtraction.
Yeah,
Four.
yeah.
It's just subtraction.
Just subtraction.
Of
Wait,
coordinates.
W.
In
It's
addition.
super simple.
Yeah.
W.
But it's okay. It is, the concept's complicated, and this part of the
You're gonna
math
click like
is
next
easy.
page, and then it's gonna be like cosine of all this crazy stuff.
Okay, no, what?
Yeah.
Are we so far so good?
Wait, I'm
Yeah.
so confused about W.
What about it?
The next page is going.
Oh, because it didn't come up on here anymore?
Log
That's
cosine
true.
of
No, like
43.2
minus
multiplied
Yeah, of W, not
3.235.
W was
Just like
W
subtract
squared
before.
minus Y.
Wait, no,
I.
yeah, tell me the
plus
question,
I
sorry.
to
This would be W.
vector.
Is no way.
Oh, you subtract like, cause the
Yeah.
first one from each.
Exactly,
Minus
right?
one,
So-
two.
The
So if
two
I
X's
W
and the
minus
two
V,
Y's.
it's 3 minus 2,
Yes.
and 4 minus 5,
I get it.
right?
Minus 2.
Right? And if I did V plus 2W, it would be -2 plus 6, right? That's 2W, and 5 plus 8.
Wait, how? Why you minus it? Like how? Like if you were not to do the subtraction, how do you visualize it in the graph?
If I was not to do what?
Yeah, like the W minus V.
Mm-hmm.
So if you are not to subtract it directly, how do you visualize the graph?
If I was to visualize this on the graph,
Yes.
right? I'd take this vector right here,
Right.
I'd flip it, and have it go in this direction, right?
Okay, cool.
So, let's say,
Sorry, I don't have.
that's okay. No, I want you guys to see it. It's important, I think. Right? So I gotta get down there. Okay. Right. So this is negative v, right? Then this would be w minus v. And that gets me to the 5, negative 1.
What's the difference between that compared to w plus negative?
Same thing.
So you're saying
Right,
that
it's like,
in
what's,
a way it's the same answer, like it's
Definitely.
Okay.
right? It's
Wait,
the same thing as like, it basically,
I
the
get it.
underlying concept of that question is that addition and subtraction are
Then
the
on
same
the
thing.
other one, on like the one
Yeah.
where it's like the rectangle, why doesn't
Okay.
Yeah.
why doesn't the
I'm just telling you.
Okay, great.
on the rectangle you just showed us, why doesn't the like v minus u and the v plus negative u end in the same place?
That's more to the concept of doesn't matter. Doesn't matter the position of the vector, it just matters the direction of the line.
Oh, okay.
Okay? That's a conceptual question. Yours was a conceptual question about addition and subtraction.
Yes.
Multiplication and division are also the same thing.
Yeah. Thank you.
No problem. Yeah, so those are all the different representations of how you could add all those things together. Lovely. Oh, I hate you,
See, I
board.
told you it has serious problems.
Oh.
It has mental breakdown.
Oops.
This is no big deal. We just talked about this, right?
Yep.
U plus V is the same as
What's
V
C
plus
plus
U.
D?
This actually seems like all. This is just like basic math.
Yeah, this is like this stuff is all basic math, but it's tied in with a new concept. That's why it's challenging.
Yeah.
What's that?
Like scalars.
You get this?
Yeah.
Scalars?
C and D are scalars, right? Which just means it's a measurement with magnitude, right?
Oh, serious.
So that'd be like the same thing as when I did 2W. 2 would be the scalar that I multiply by W, okay? Right? So yeah, this might be like a little bit of an intimidating page, but if you look through each one, it's just saying if I multiply a scalar
So,
to a
like,
vector, I can multiply it in
Is
any
a scalar
order.
just like a real number?
It's just any number,
Okay.
right?
Oh,
Right? And it couldn't represent a measurement, but it's just a number without direction.
What does 9 mean?
9, the magnitude of CV is equal to the the magnitude of two vectors multiplied by each other is equal to the magnitude of one times the magnitude of the other, right? I can either multiply the two vectors first and then find the magnitude of that, or I can find each one.
Wait, but those
individually.
aren't two vectors. That's a scalar and a vector.
Oh, CV?
Yeah.
Oh, sure. So it's
Oh,
just saying
yeah,
the
exactly.
magnitude of the scalar,
Oh, I
which,
thought-
is, which is always going to be.
I thought
Right.
it was you.
Oh, the
This
Times
actually
the
says the
magnitude.
same
Yeah, that
thing.
makes
Pretty.
sense.
This one says pretty much the same thing as this.
Alright. Yeah, what happens when U times
are
V?
those vectors.
When I multiply two vectors,
Yes.
we're not going there yet.
Oh,
Okay?
Not yet.
Not yet. I think that's it for that.
Oh,
We're gonna do 2 days on this chapter. So
How long
do we have class on Saturday?
we've got tomorrow.
Oh, good.
Yeah.
We don't have it on Saturday.
Okay. No. It's FED.
Say bye to these guys. There's no way they watch this far.